Good afternoon, class. We are looking at Chapter 7, Trigonometric Identities and Equations, also known as Analytic Trigonometry, 7.3 Double Angle and Half Angle Formula, 7.5 Solving Trigonometric Equations. So we covered trigonometric equations, identities, sum and difference formulas, and now we're going to go to double angle and half angle formulas as well as solving trigonometric equations. So we're going to use, the objectives are to use double angle formulas to find the exact values, use double angle formulas to establish identities, half angle formulas to find exact values, use double angle formula to solve equations. Reminding you of the properties that we have discussed, fundamental identities, sum and difference formulas, even and odd properties. Remember, all trigonometric functions are odd except cosine and therefore secant. Periodic functions, they are all periodic. The period for all of them is 2 pi except tangent and therefore cotangent is pi. And here's the fundamental identities. We should be very comfortable with Pythagorean identities, quotient identities, reciprocal identities. So from there we can get to double angle formulas such as sine of 2 alpha is 2 sine alpha cosine alpha, cosine 2 alpha is cosine squared minus sine squared, and so on. Cosine 2 alpha has 3 different formats. So from here, if you solve for sine squared, you get 1 minus cosine 2 alpha. And of course, you can go with half angle. If you cut this in half, you have to cut this in half. From here, if you solve for cosine squared, you get 1 plus cosine 2 alpha over 2. And if you cut this in half, you get cosine squared of alpha over 2. Now, tan is sine over cosine, so the ratio of these two. Cut it in half, becomes alpha over 2, this becomes alpha. And then sine of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 2, and the rest of it, all of which we use the quadrant they belong to make a decision whether they are positive or negative. So that's the summary. Let's look at the proof of some of those. So we want to prove that sine of 2 alpha is 2 sine alpha cosine alpha. So we are going to use the fact that we proved sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. So instead of beta, we are going to use alpha. So that's sine of alpha plus alpha. So if I replace this beta with alpha, becomes sine alpha cosine alpha. So all the betas are replaced with alpha. Sine alpha cosine alpha plus cosine alpha sine alpha. They are identical, right? Doesn't matter in what order, sine alpha, cosine alpha, or cosine alpha, sine alpha, there are 2 of them. So that's a proof that sine of 2 alpha is 2 sine alpha plus cosine alpha. So very straightforward. We want to prove cosine of 2 alpha is cosine squared alpha minus sine squared alpha. So we are going to write cosine of 2 alpha is cosine of alpha plus alpha and use this. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, and replace the beta with alpha. So cosine alpha minus sine alpha, and that makes it cosine squared alpha minus sine squared alpha. Now, Pythagorean identities, we can replace the sine squared, we can replace the cosine squared and see what happens. If we replace the sine squared with 1 minus cosine squared, so that means minus 1 plus cosine squared. So if we replace this, everybody, we replace this, we get minus 1 plus cosine squared. So cosine of 2 alpha is 2 cosine squared alpha minus 1. But instead of that, if we replace it with cosine squared alpha equals 1 minus sine squared, if we use this one, going back to the original one, replace the cosine squared with 1 minus sine squared. Let me clean up and let me just replace this with 1 minus sine squared. That gives us 1 minus 2 sine squared. So Pythagorean identities help us prove that cosine of 2 alpha has 3 different versions. Cosine of 2 alpha is cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. And they are all handy. Now over here, if I want to solve for sine squared, first of all, I'm going to move this one this way. I'm going to move this one that way. And then if I divide by 2, I get sine squared alpha is 1 minus cosine 2 alpha divided by 2. This one, I'm going to move the negative 1 to the left. I get cosine of 2 alpha plus 1, or 1 plus cosine 2 alpha, equals 2 cosine squared alpha. So what is cosine squared? Divide by 2. Divide by 2. So far, so good. What about tan squared? Sine squared over cosine squared. Tan squared is sine squared over cosine squared. If you divide this one by this one, I hope you realize the 2's drop. So this goes at top, 1 minus cosine 2 alpha. This goes at the bottom, 1 plus cosine 2 alpha. So very straightforward, everybody. Now, let's cut them in half as follows. If I cut this in half, in other words, you can let 2 alpha be theta for the sake of argument, just for so you see how that works. Let's say, let that one be theta. Then this becomes what? Theta over 2. This becomes what? Theta. That's why if you cut it in half, the angle, and that's fine. You can say this is alpha over 2. You're going to replace this with alpha and this one with alpha. And the rest of them follow in the same manner. So we're going to cut this in half. 2 alpha becomes alpha. And this is cosine squared of alpha over 2. This is the concept of a half angle. The same thing. Alpha becomes alpha over 2. And 2 alpha becomes alpha. We want to prove tan of 2 alpha is 2 tan alpha over 1 minus tan squared alpha. Recall, tan of alpha plus beta is tan of alpha plus tan of beta over 1 minus tan of alpha tan of beta. So all you have to do in this formula, replace the beta with alpha. So you get tan of alpha plus alpha is tan of alpha plus tan of alpha over 1 minus tan of alpha tan of alpha. This means 2 tan alpha. This means 1 minus tan squared alpha. It's pretty straightforward, everybody. We recall this from the previous page. We showed this is the case. Therefore, what is cosine alpha over 2? Take a root, plus minus. We showed sine squared alpha over 2 is 1 minus cosine alpha over 2. So what is sine alpha over 2? Take a root, plus minus. We showed tan squared alpha over 2 is 1 minus cosine alpha over 1 plus cosine alpha. We showed that. So what is tan of alpha over 2? Take a root, plus minus. So sine of alpha over 2 plus minus the square root of 1 minus cosine alpha over 2. Cosine of alpha over 2 plus minus 1 plus cosine alpha over 2. Tan of alpha over 2 is plus minus the square root of this over that. 1 minus cosine alpha, 1 plus cosine alpha. All of which the sine comes from the quadrant. We make a decision based on the quadrant, everybody. We're going to discuss this further in the next page. Sine of alpha over 2 is sine alpha over 1 plus cosine alpha. So we continue with the proof, and this is the key, everybody, where the plus or minus sign is determined by the quadrant of the angle alpha over 2. You have to make that decision. So that we showed, we're going to look at these two also. So we showed that sine squared of alpha over 2 was 1 minus cosine alpha over 2. So if I multiply both sides by 2, I can put the 2 here. 2 sine squared alpha over 2, and it's equal to the numerator, 1 minus cosine alpha. Tan of alpha over 2 is sine over cosine. So I can say sine of alpha over 2 over cosine of alpha over 2. I can multiply the top and the bottom by the same thing. In this case, I choose to multiply by 2 sine alpha over 2, 2 sine alpha over 2. Now the numerator becomes 2 sine squared alpha over 2. And the bottom becomes 2 sine alpha over 2 cosine alpha over 2. Why did I do that? Well, the numerator 2 sine squared alpha over 2 can be replaced by 1 minus cosine alpha. 2 sine alpha over 2 cosine alpha over 2, we should recognize this as sine of alpha because sine of 2 alpha is 2 sine alpha cosine alpha. Let me write that, so reminding you that because sine of 2 alpha is 2 sine alpha cosine alpha, this is the reason. Okay, so if I cut this in half, becomes alpha, then I cut this in half. So the top is what you have here, the bottom is sine alpha. So that's one of them. We proved this one. And now if I multiply this by the conjugate of the numerator, meaning 1 plus cosine A over 1 plus cosine A. The numerator we write it as a product. The denominator we write as a product. The numerator becomes 1 minus cosine squared because we have A minus B, A plus B. So A minus B, A plus B is A squared minus B squared, 1 minus cosine squared. And as you know, 1 minus cosine squared is sine squared. And these two cancel each other. The numerator becomes sine alpha. And that's the third one. So tan of alpha over 2. You can go with plus minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Or 1 minus cosine alpha over sine alpha. Or sine alpha over 1 plus cosine alpha. There are 3 different ways of finding it. All right. If sine theta is 3 over 5 and theta is between pi over 2 and pi, find the exact value of sine 2 theta, cosine 2 theta. By the way, pi over 2 to pi means quadrant 2, just for the sake of argument. As you know, in quadrant 2, sine is positive. So we want to find sine of 2 theta. We're going to use 2 sine theta cosine theta. And that means I have the sine, I'm in good shape, but I don't have the cosine, and I have to find it using one method, either the circles, okay? Remember, cosine is x over r, sine is y over r, and things like that, or identities, plus minus square root of 1 minus sine squared. I'm assuming we remember fundamental identities, and therefore, if sine squared plus cosine squared is 1, cosine is plus minus square root of 1 minus sine squared theta. I'm going to write that because you really should know that from sine squared plus cosine squared equals 1, a lot of formulas come out, okay? One of them would be this, okay? Because cosine squared is 1 minus sine squared, so this is plus minus. So we're going to plug in and evaluate it where sine is given as 3 over 5. You square it, you get 9 over 25. 1 minus that is 16 over 25. Which is plus minus 4 over 5. You have to make a decision, positive or negative. And it is negative. Why is that? Because in the second quadrant, sine is positive, but cosine is negative. So this becomes negative because it's quadrant 2, everybody. Quadrant 2. All right. So plug in 2 sine theta cosine theta. 2 times 3 over 5 times minus 4 over 5 is negative 24 over 25. When it comes to double angles, you just follow the formula. You don't have to worry about the sign. The formula will give you the proper sign. For cosine 2 theta, we have different ways of approaching it. Class, we can go with cosine squared minus sine squared. And since we have both of them, that works. We can go with 1 minus 2 sine squared. Again, we have the sign that works. Or we can go with 2 cosine squared minus 1. There are 3 different formats. Any of them will do the job since we found everything. However, here's what I want to add. If we didn't have part A, meaning we wouldn't have to find cosine theta, then I would stick with 1 minus 2 sine squared because I don't have to calculate anything. I just use the sign. Again, let's assume part A wasn't given. Let's assume we didn't have to calculate that. For this one, we wouldn't use this formula. We would use the formula that uses sine only, which is 1 minus 2 sine squared. In this case, we just plug in, and I'm going to clean up my mess. So this is 16 over 25. This is 9 over 25. The difference is 7 over 25. And that's, again, the answer that you don't have to worry about the sign. The formula will give you the proper sign. Cosine 2 theta is 2 minus 2 sine squared theta. And we want to solve this. This is an equation, class. This is not an identity, okay? Conditional, if you will. You want to solve that. And because the right side involves sine squared, then cosine of 2 theta, there are 3 different ways. We are going to go with the one that has sine squared only. So we are going to go with the third method, 1 minus 2 sine squared. So 1 minus 2 sine squared, and you don't have to even move things around. These two are identical, drop it. 1 is not equal to 2. That means there is no solution. This is phi, again, reminding you in Greek letter, and that means an empty set. That means no solution. So that doesn't work. No matter what, this doesn't work. Sine of 2 theta plus cosine of 2 theta is equal to 0. There are a couple of different ways of solving it. One of them is to raise it to the power of 2 and solve it. It results in sine squared and cosine squared. They add up to 1. One is because you have only sine and cosine and nothing else, move one of them. Doesn't matter which one. Becomes negative on the other side, in this case cosine. So becomes negative cosine 2 theta. Divide both sides either by sine or cosine to get into tangent or cotangent. So we're going to divide both sides by cosine of 2 theta. So it's pretty straightforward. When you do that, what happens? The left side is sine over cosine. That is tangent of 2 theta. The right side is just a -1, everybody. -1. Very straightforward. Now, as you know, tan of 2 theta is equal to negative, and theta is 1 when it's pi over 4, and it's -1 when it's 3 pi over 4. Okay, tangent is negative in the second and fourth quadrant. So 2 theta equals 3 pi over 4 plus n pi. The way we do multiple angles, this is multiple angles, okay? N theta, multiple angles. To find them in the first revolution from 0 to 2 pi, you have to add their period. In this case, it's pi, so times n pi. If it were sine or cosine, you would say 2n pi, and then you divide by 2 and you solve them. So when we divide by 2 this one, it gives us theta equals 3 pi over 4 divided by 2 is 3 pi over 8 plus n pi divided by 2, and you choose n to be 0, 1, 2, 3. In other words, the reason you double this up because it's pi, otherwise you don't, you write both. There are two answers for others like sine and cosine, and then you go 0 and 1. In this case, 0, 1, 2, 3. If you plug in 0, you get 3 pi over 8. We are interested in one revolution, and then if need be, you can add k pi. So 3 pi over 8 if you choose n to be 0. But if you make it 1, remember pi over 2 is 4 pi over 8. Let me just write this here so you can see that as pi over 2 is 4 pi over 8, right? Therefore, if I choose 1, 4 pi and 3 pi, 7 pi over 8. If I choose a 2, 2 times 4, 8 pi and 3 pi, 11 pi over 8. If I choose 3, 3 times 4, 12 pi, and 3 pi, 15 pi over 8. Okay, so n 0, 1, 2, 3, and we get those. Now, what if I pick a larger number? I want to make it 1. If I pick 4, what happens? If you pick 4, 4 times pi over 2 is 2 pi. 4 times pi over 2 is 2 pi. That goes beyond the 0 to 2 pi. Okay, just reminding you of what we have done before, multiple angles when you want to solve. Example 3, let's establish identity. Write cosine to the power of 4 theta in a format that does not involve powers of sine or cosine. Let's see how we do that. So cosine to the power of 4 is cosine squared to the power of 2. Cosine squared, if you wanted to involve cosine only, is 1 plus cosine 2 alpha over 2. So this is 1 plus cosine 2 theta divided by 2. Alpha, beta, gamma, theta, x makes no difference. We should be able to make the transition from one variable to the next. So 2 theta. So we want to square that. First, let's get rid of the 2 and put 1/4 because it's being divided by 2. So 1/4, and then square that, which is 1 plus 2 cosine 2 theta plus cosine squared 2 theta. I'm assuming we have no problem with this, okay? If it's negative, we get a negative here. Okay, so we should have no problem. So This is good, 1/4. This is good, 1/2. And this is 1/4 of this. And this is the one that has a power. We don't want to have a power. We're going to fix that. Imagine 2 theta was x. Okay. And never mind the 1/4. Cosine squared of, or you can think of it as alpha. So 1 plus cosine of 2 alpha divided by 2. So 2 times 2 theta divided by 2. So imagine it's x. Cosine squared of x is 1 plus cosine of 2x divided by 2. So 2 times x, 2 times 2 theta. And so we're going to do this again. We are going to say, okay, this is fine, 1/4 and 2, that makes it 1/8 because it's 1/2 class. 1/8 of 1 plus cosine of 4 theta. Again, this is the x we were talking about, okay? Now we have 2 of those, 2x. This is the 2 we are referring to. All right, let me erase mine so we can see that. So this is 1/8, and this is 1/8 cosine of 4 theta. And now these two, class 1/4 is 2/8. They add up to 3/8. And you just write the rest of it. 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. Okay, so pretty straightforward. Let's solve trig equation. Cosine 2 theta, cosine theta minus sine 2 theta, sine theta is 1/2. These are the sum formulas, and we notice this is in essence cosine alpha, cosine beta minus sine alpha, sine beta, where alpha is 2 theta, beta is theta. I hope you can see that. Therefore, this is cosine of alpha plus beta, right, everybody? This must be cosine of 2 theta plus theta. Therefore, cosine of 3 theta is 1/2. Or cosine x equals 1/2, and you know cosine is 1/2 when it's pi over 3 in the first quadrant. So if we think of this as x, cosine x equals 1/2, and then x is pi over 3, or better yet, x sub r, that means the reference arc. Remember, cosine is positive in the first quadrant and in the fourth quadrant. In which case, we are going to write 2 pi minus the reference arc. That means 2 pi minus pi over 3. That means 5 pi over 3. So 3 theta is pi over 3 plus 2k pi. Also 5 pi over 3 plus 2k pi. Remember, whenever you have multiple angles, you have to write in this format. You're going to divide by 3. So if I divide by 3, I get theta. This becomes pi over 9. This becomes 2k pi over 3. Divide by 3, let me just do this. So what color do I want to use? So this is divided by 3. And this one is divided by 3. Same thing here. So we get pi over 9 plus 2k pi over 3 and 5 pi over 9 plus 2k pi over 3. If we wanted to have the following, everybody. If we wanted to get the answer from 0 to 2 pi, then we let k be 0, 1, 2, if that was the question. So if you replace the k with 0, 1, 2, you get this one here, the same thing here. You get a total of 6 answers, okay? So this has 2 answers, x. If it's double angle, it has 4 angles, 4 answers. If it's triple, it has 6 answers. That's how it works, everybody. An object is propelled. We are looking at an application, projectile motion. An object is propelled upward at an angle of 45 degrees to 9 degrees. Theta somewhere between the two. To the horizontal with an initial velocity of v sub 0 feet per second. If air resistance is ignored, the horizontal distance r that it travels is given by 1/16 v0 squared sine theta cosine theta v sub 0. That's the initial velocity. Part A, show r equals 1/32 v sub 0 quantity squared sine of 2 theta. Well, we are going to rewrite this, and we notice that this part, if it had a 2, would be 2 sine theta cosine theta would be sine of 2 theta, but it's not. So this part is half of sine 2 theta. Sine 2 alpha is 2 sine alpha cosine alpha. So this part in yellow is half of sine 2 theta, half times 1/16. That's 1/32 v0 squared sine 2 theta, and that's the proof. Part B, find theta to maximize R. So we want to maximize this R. The limit is on the sign. The sign goes somewhere between -1 and 1. To maximize this, you want to maximize the sign. Maximum value of the sign is 1. To maximize R, you want to maximize the sign. Maximum value of sine is 1. So sine of 2 theta is 1. That means 2 theta must be pi over 2, and theta must be pi over 4. And that's all there is to it. Pretty straightforward. At the angle of pi over 4, it will maximize the range. R stands for the range, by the horizontal distance range. Use half-angle formulas to find exact values. Use a half-angle formula to find the exact value of sine of 22.5 degrees. Now, of course, 22.5 is half of 45. So 45 over 2. By the way, we have again plus minus, but 22.5 degrees clearly is in the first quadrant, and therefore positive. Okay, in the first quadrant, everything is positive. So we don't have to worry about that. So plus minus the square root of 1 minus cosine alpha over 2 just becomes plus. So this is the formula, but we use the plus because it's in the first quadrant. And square root of 1 minus cosine of 45 degrees over 2. Now 45 degrees is a common arc. Cosine is square root of 2 over 2. Under the radical, we have a complex fraction. Let's multiply the top and the bottom by LCD, namely 2. When you multiply the bottom, you get 4. When you multiply the top, you get 2 here minus square root of 2, and 4 comes out as 2. So again, this 2, 4 comes out as 2. 2 times 1 is 2, and this one cancels out the 2. This is the answer. You're done. What about cosine of 5 pi over 12? Well, 5 pi over 12 is half of 5 pi over 6. And I have mentioned it before. I'm going to mention it again. Just remember that pi over 6 is 30 degrees. Pi over 12 is 50 degrees. That may be helpful to remember, okay? All right, so cosine of 5 pi over 6 divided by 2. And we are going to use the fact that cosine of alpha over 2 is 1 plus minus the square root of 1 plus cosine alpha divided by 2. And remember, 5 pi over 12, 6 pi over 12 is pi over 2. 5 pi over 12 is less than that, and that's in quadrant 1 also. Quadrant 1, positive. Okay. Cosine of 5 pi over 6 is the same as pi over 6. Cosine of pi over 6 is square root of 3 over 2, but in the second quadrant. Cosine is negative. So square root of 3 over 2, negative, so minus square root of 3 over 2. One more time. In this case, pi over 6 is the reference arc. Let's just write that. The reference arc for this theta r is pi over 6. So it's the same as pi over 6. What is cosine of pi over 6? Square root of 3 over 2. What about 5 pi over 6? Second quadrant makes it negative. Again, let's multiply the top and the bottom by 2. This 2 becomes 4 and comes out as 2. This times 1 is 2, and this one cancel out, minus square root of 3. And we are done again. In this case, I didn't write it. In this case, I'm writing it to show you. Don't have to worry about that. It's very straightforward. Use half angle formulas to find the exact value. If cosine is negative 1 over 5, cosine of alpha, and alpha is between pi over 2 and pi, find the exact value, first and foremost. This is quadrant 2. And half of it makes this one pi over 4, makes this one pi over 2, puts it in quadrant 1. So all of them are in quadrant 1. All of them are positive. So you have to figure out the sign, it's positive. The reason why we have plus minus here. So sine is the square root of 1 minus cosine alpha over 2. And we plug in cosine alpha is negative 1 over 5. Negative times negative makes it positive. So you add them up to 6 over 5. Divide by 2, you get 3 over 5. You multiply by 5 over 5 right here. These two come out as 5, and these two remain as square root of 15. And again, positive. We're talking about the first quadrant for the half angle. Cosine uses the same thing with the plus in between. Okay? Same formula with the plus in between. So 1 plus, this number is negative. And so you subtract it, you get 4 over 5. This was 6 over 5, this is 4 over 5. Divide by 2, you get 2 over 5. Again, you multiply by 5 over 5, and this comes out as 5, and this remains inside as square root of 10. Now, for tangent, I'm not going to use any of those because I have those two. If I didn't, plus, if I didn't calculate sine, I didn't calculate cosine, I have no choice but to use one of those formulas. But I've already done the work. So I'm going to write tangent is sine over cosine, this one over this one. I take the easy way out. I plug in. You have a complex fraction, they have the same denominator. You can drop it square root of 15 over square root of 10. And by the way, I hope you recognize you can put this under the same radical, becomes square root of 3 halves. And then you rationalize and you get square root of 6 over 2. The purpose of this question is to understand this part. These are all elementary algebra. Nobody should have any problem with. Okay, those are dealing with numbers, rationalizations, and so forth. So that should be very straightforward, everybody. Cosine alpha is given as negative 3 over 5, and alpha is between pi and 3 power 2. That means, just for the sake of argument, that means quadrant 3. But that's really not important. We cut it in half. Half, half, half. This becomes power 2. This becomes 3 power 4. And that puts us in the second quadrant, quadrant 2, everybody. So we know things are in quadrant 2. In quadrant 2, the only thing positive is sine, right? And of course, with sine goes cosecant. Everything else is negative. So sine, the square root of 1 minus cosine alpha over 2, we have used it, and sine is positive. 1 minus this number makes it plus. So 1 and 3 over 5 is 8 over 5, everybody. Divided by 2 is 4 over 5. And it comes out as 2 over square root of 5. You could have rationalized it right down there. But in any event, the bottom is 5 and the top is 2 square root of 5 over 5. So it has to be rationalized, everybody. In some instances, they may not care too much. Cosine definitely is negative. So you put the negative, use the negative, and 1 plus cosine alpha over 2 under the radical. And this becomes 2 over 5. Divided by 2 is 1 over 5. We have this negative sign. Everybody is not going anywhere. And now, just take it out, rationalize it. You get minus square root of 5 over 5. Tangent, again, I'm not going to use the formula that I have here. I don't need to because I have the sine and cosine. The ratio of these two is the answer. Sine over cosine. Sine of alpha over 2 over cosine of alpha over 2. The denominators are identical, drop it. So you get 2 square root of 5 over minus square root of 5. Negative 2. We'll establish identity. Sine of 4 theta is cosine of theta times 4 sine theta minus 8 sine cubed theta. You start with one side when you want to establish identity. Normally the one which is more complicated. Let's start with the right hand side. And we notice inside the parentheses, I can take out the common factor of 4 sine theta. If I take this out, this gives me 1. This gives me negative 2 sine squared theta. We have 4 sine theta, cosine theta. So sine 2 theta is 2 sine theta, cosine theta. There are 4 of it. So that means this is 2 sine 2 theta, class. Let me write this as 2, let me use a different color. 2 times 2 sine theta, cosine theta. So 2 sine 2 theta. And this you should know it's cosine 2 theta. Therefore, we have 2 sine 2 theta, cosine 2 theta. Let's assume theta is x, everybody. What color do I want to use? Let's say 2 theta is x. So 2 sine x cosine x is sine of 2x. That means sine of 2 times 2 theta, sine of 4 theta. And that's the proof. This looks like the left-hand side, everybody. Very straightforward. ln of cosine theta, let me grab the laser pointer. ln of cosine theta is half of ln of 1 plus cosine 2 theta minus ln 2. We want to prove this. So we start with the more complicated side. It seems to be the right-hand side. I hope you remember all the logarithmic properties. So we are going to use number 6, the quotient rule, and we are going to go from right to left. So 1/2 ln of this over that, ln of 1 plus cosine 2 theta over 2. Now we're going to use number 7. This 1/2 becomes the exponent. Remember, this is called the power rule. This is called the quotient rule. In the case of the power rule, the power sits in front, becomes a coefficient. So it's sitting in front. You can take it back and make it a power. So I take the 1/2 and make it a power. 1 plus cosine 2 theta divided by 2. As you recall, according to this is cosine squared alpha. This must be cosine squared theta. Cosine squared theta to the power of 1/2, they cancel each other. It's simply cosine of theta in absolute value sense, which is equal to the left-hand side. Pretty straightforward, everybody. We want to solve this equation, cosine 2 theta plus 5 cosine theta plus 3. Now, bear in mind, cosine 2 theta, there are 3 different ways of writing it. You look at these two, and since this involves cosine, you definitely don't want to go with cosine squared minus sine squared. You don't want to go with 1 minus 2 sine squared. You want to go with 2 cosine squared minus 1 because you want to make it a function of cosine and of quadratic form. So this is changed to 2 cosine squared minus 1. And now 2 cosine squared theta plus 5 cosine theta plus 2. You can factor it easily because 2 is a prime number. So this is 2 cosine theta. This is 1 cosine theta. And 2, you have no choice but to go with 1 and 2. Okay. You have to figure out where to put it. And both of them positive or both of them negative. You work it out, you end up with this situation. So the first one says cosine theta must be negative 1/2. The second one, cosine theta must be negative 2. First and foremost, this has no solutions because cosine is between negative 1 and 1. Secondly, I'm going to remind you, you look at cosine theta equals 1/2, gives you the reference arc of a pi over 3. Now, to make this negative quadrant 2, pi minus the reference arc, quadrant 3, pi plus the reference arc. So in quadrant 2, pi minus pi over 3 is 2 pi over 3. In quadrant 3, pi plus that, or pi over 3, and that's the final answer. All right, we're going to establish the identity that 4 sine u cosine u times 1 minus 2 sine squared is sine of 4u. So we start with one side. In this case, the more complicated side is the left-hand side. Now, never mind the 4, you know 2 sine u cosine u, that would be sine of 2u, according to this one. So think about 4 as 2 times 2. This part is sine 2u, so we have 2 of those. This one is simply cosine 2u. So we write 2 sine 2u cosine 2u, and that ends up being sine of 4u. We've seen a similar question before. Cotangent theta minus tan theta over cotangent theta plus tan theta is cosine of 2 theta. Seems to me the left-hand side is more complicated, and we just write it. And the way we write it, class, Cotangent, we change everything to sine and cosine. Cosine over sine, tangent sine over cosine. Now you have two choices. I would multiply by LCD. Remember, there are four fractions, 1, 2, 3, 4. And sine theta, cosine theta is the LCD. Multiply everything by it, and that fixes the problem. Or take a common denominator of sine theta, cosine theta for the bottom and top. That works the same way. If you go that route, it's cosine squared minus sine squared. This is cosine squared plus sine squared. And they have the same denominator, sine theta, cosine theta. We are taking a common denominator. So whenever you have a complex fraction, if the denominators are identical, you can drop them. The reason being is because you multiply these two, you put them at top. You multiply these two, you put them at the bottom. Okay? These two. And so you can drop and say you have cosine squared minus sine squared over cosine squared plus sine squared. Now cosine squared plus sine squared is 1. And the numerator cosine squared minus sine squared is cosine of 2 theta. And that's a proof, and we are done. Show that the area of an isosceles triangle, remember isosceles triangle, two sides are equal, two angles are equal, is A equals to half of S squared sine theta, where S is the length of one of the two equal sides. This is S, this is S. And theta is the measure of the angle between them. So the included angle is theta. Each side has the size S, and we want to prove the area is that. Well, regardless of what we have, we know the area of a triangle is 1/2 base times the height. So if you take this to be the base, each side is half. If this is angle theta, each side is theta over 2. So this is b over 2. This is theta over 2. Again, we are taking this to be b, okay? And we know this is theta. So that's why it's theta over 2. So all you have to do, calculate the b and h and plug it in and see what happens. So if we use this triangle, sine of this angle, sine of theta over 2 is the opposite, which is b over 2 over the hypotenuse, which is s. Sine of theta over 2, b over 2 over s. So what is, I can multiply this one by s and then by 2, and b becomes 2s sine theta over 2. I hope you can see that. B over 2 is the product of these two. Multiply both sides by 2. So that's B. What about cosine? Cosine of this angle is the adjacent H over the hypotenuse S. Therefore, H is the product of these two. Now, plug it into this. 1/2 the base, 2s sine theta over 2, H, S times sine cosine theta over 2. So this S and this S, it was S squared. Let's take that out, make it half of S squared, and leave the rest of them in. What is in? Number 2 remains. Sine of theta over 2 remains. Cosine of theta over 2 remains. Sine of 2 alpha is 2 sine alpha cosine alpha. So this should be sine of 2 times theta over 2. Which makes it sine of theta. So half of S squared sine theta. And that's the proof. And we are done. Well, pretty straightforward. A rectangle is inscribed in a semicircle of radius 1 with one of its sides on the diameter of the semicircle. Express the area A as a function of theta. Well, any rectangle, the area is the length times the width. So the smaller side is the width y, the larger side x times 2, because if this is x, so is this one. This is x also, right? So the length is x and x, 2x. The width is the smaller side y. So we have 2xy. All we have to do, calculate x, calculate y, see what they are. So in this triangle, sine of theta, so let me see what color do I want to use. This one. Okay. Sine of theta is the opposite y over the hypotenuse, and the hypotenuse is 1. What color should I use? 1. Right? Because this is 1. So one more time, sine theta is y over 1. Cosine theta is x over 1. So this is, maybe I erase my work. This is 1. Sine theta and cosine theta. Sine theta is y over 1 or y. Cosine theta is x over 1 or x. So we are going to replace the x with cosine, y with sine. We get 2 cosine theta, sine theta. It doesn't matter in which order. This is sine of 2 theta. So that the second part that says show that this is just sine of 2 theta. That's what it is. Okay. It's pretty straightforward. There's really not much anybody can do. It's just right here. It's the formula. All right. Find the dimensions of the rectangle to get maximum area. Also find the maximum area. Again, we are dealing with a situation where we are dealing with sine, and sine has a maximum value of 1. The maximum area is when sine 2 theta is equal to 1 because the area is sine 2 theta. So when would that be? When 2 theta is pi over 2, because sine of pi over 2 is 1. So theta must be half of that, pi over 4, or 45 degrees. Now x is cosine of 45 degrees and y is sine of 45 degrees. Both of them are square root of 2 over 2 class. So x cosine theta or cosine of 45 degrees, y sine theta or sine of 45 degrees or pi over 4, square root of 2 over 2. And again, if you plug in, because the answer is sine 2 theta, the answer is 1, but if you even plug it into 2xy, 2 times square root of 2 over 2 times square root of 2 over 2, that is also 1. Okay. So right here, the answer is 1 anyways. Use double angle formula to establish identity, develop a formula for sine of 3 theta. Well, we know that sine of alpha plus beta. So we cut the 3 theta into 2 theta and theta. And now we use this identity. Sine alpha cosine beta. So sine 2 theta cosine theta plus cosine 2 theta sine theta, according to this. This one is 2 sine theta cosine theta. This one, we have 3 different ways. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Use one of them, and then we'll see what we want to do. If you use any of them, ultimately you decide what to do afterwards, after you do the simplification. So for example, we use cosine squared minus sine squared. Let's see what happens. So here we have 2 sine theta cosine squared. Here we have plus sine theta cosine squared. Here we have negative sine cubed. In other words, distribute. These two, they can add up because we have sine theta cosine squared. They can add up to 3 sine theta cosine squared theta. And now everything is in good shape. We want to change everything to sine, and we are going to change this to 1 minus sine squared. If we do that, here's what happens. 3 sine theta times 1, that's 3 sine theta. 3 sine theta minus sine squared theta. The product of these two, minus 3 sine cubed. This one remains unchanged. However, these two, we can combine them into minus 4 sine cubed. So the final answer is 3 sine theta minus 4 sine cubed theta. So sine of 3 theta as a function of sine is 3 sine theta minus 4 sine cube theta. If you had written 1 minus 2 sine squared here, again, you would be close and another manipulation would have given you the answer. We're going to continue with working on that. If sine is 1 over 6 and theta is between 0 and power 2, so right here it puts us in the first quadrant. We want sine of 2 theta, cosine of 2 theta. Never worry about the sign, just follow the formulas for those. But for half angle, you have to follow the sign, and half of that 0 is 0, power 2 becomes power 4, puts you in the first quadrant and makes those positive also. But these two you never have to worry about. So we are going to go with 2 sine theta, cosine theta. That means we have sine, but we don't have cosine. We have to find cosine. And cosine is plus minus the square root of 1 minus sine squared. And replace the sine with 1 over 6. So we get 1 over 36 here. 1 minus that is 35 over 36. This is 35 over 36. 36 comes out as 6. And we use the positive only because this is in the first quadrant. And in the first quadrant, everything is positive, including the cosine. The only thing you want to be careful of, you have to figure out the sign for this guy. It's in the first quadrant and it's positive. And so now you can plug in. When you plug in 6 times 6, 36, and the two cancel each other, they become 18, or you can say 2, this gives you 3. So square root of 35 over 18. Now, cosine 2 theta, it doesn't matter which formula you use, you have sine and you have cosine. Again, if you just had this one, I would use 1 minus 2 sine squared. I wouldn't even bother to find cosine squared. But I have both of them, it doesn't matter. Cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. All of them give you the same answer. So when you square them, this becomes 35 over 36, and this becomes 1 over 36. So 34 over 36, or 17 over 18. Pretty straightforward, everybody. Now, as far as the sine of half angle, again, half of this class puts us also in quadrant 1. Everything is positive in quadrant 1. So sine plus minus, you just use the plus 1 minus cosine divided by 2. And cosine is that square root of 35 over 6. Because the numerator has the denominator 6, let's multiply it by 6 and divide by 6. Divide by 6. This way, the numerator becomes 6 minus square root of 35. The denominator becomes 12, which is 4 times 3. 4 comes out as 2. So I hope you understand what happened here. Maybe where do I have room to write this? Let me use a different color. Let me just erase this and let me use a red one. So what we have here is 6 minus square root of 35 over 12 under the radical, everybody. So this remains 12 is 3 times 4. the 4 comes out, becomes 2. That's what we have, okay? Now, do I have to go through the process to calculate this one? No, if you look at the formula, it's identical to this. Instead of negative, you have a positive here. So instead of negative, you put a positive. Same answer, change this to a positive. You don't have to recalculate. You've done all your work here. Don't waste your time repeating it. Just pay attention to this and change the sign. I think it's very straightforward. We are going to move on, everybody. Establish identity cosine alpha plus sine alpha over cosine alpha minus sine alpha minus cosine alpha minus sine alpha over cosine alpha plus sine alpha is 2 tan 2 alpha. We start with the more complicated side, the left-hand side. And clearly the best course of action is LCD. LCD, take the common denominator, just multiply these two, and that becomes LCD. Then this one times this one, that means they're identical to the power of 2, minus this one times this one, they are identical to the power of 2. So when you take the common denominator of cosine alpha minus sine alpha times cosine alpha plus sine alpha, the numerator becomes cosine alpha plus sine alpha squared, which is cosine squared alpha plus 2 cosine alpha sine alpha plus sine squared alpha minus this. So minus cosine squared minus 2 cosine alpha sine alpha plus sine squared, and we are going to change the sign of everything inside the brackets. This becomes negative, positive, negative, and there you have it. So what happens? These two cancel each other. These two cancel each other. These two add up to 4 cosine alpha sine alpha, or 4 sine alpha cosine alpha, makes no difference. And the bottom, cosine squared minus sine squared, is cosine 2 alpha. So what you're looking at, the numerator, if it had 2, would be sine of 2 alpha. It has 4, so 4 is 2 times 2, everybody. That means 2 sine 2 alpha. This part is tan 2 alpha, so 2 times tan 2 alpha is the final answer.